Hey, hello guys. In today's video, we would be learning how to draw, how to write the logic for half subtractor and full subtractor. So what is a half subtractor and what is a full subtractor? And we'll also learn how to write the K-map, that is Karnaugh map, how to write the K-map and how to draw that K-map diagram. I will be telling you about that in this video. So starting with the half subtractor similar to the half adder, it is also a logical circuit which has two inputs A and B and two outputs, which is difference here, whereas in half adder we had the sum. Here in the half subtractor we have borrow, whereas in the half adder we had the C out, carry out. So the half subtractor, it again, the truth table of half subtractor is that it has two inputs, so 2 to the power of 2. We have 4 different combinations here, which is for 0, 1, 2 and 3. So difference, how the difference is written? So the difference is written on the basis of XOR expression. So 0 XOR 0 is 0, 0 XOR 1 is 1, 1 XOR 0 is 1, 1 XOR 1 is 0. So whereas borrow, the expression of borrow is something different. So we'll check about borrow. For difference, we will write the K-map. So here we have only two inputs. So the K-map will be for the two inputs A and B. So you can write A and B interchangeably. So they have written A here and B here. So for A you have two inputs 0 and 1, so 0 and 1. For B you have two inputs 0 and 1, 0 and 1. So you have to just map the equivalent values. So for A and B 0, what value you have? You have 0. For A0 B1, for A0 B1, what value you have? 1. So 1 here. For A1 and B0, A1 and B0 you have 1. So 1 here. Whereas for A1 and B1, what value you have? You have 0. So 0 here. Now what you have to do, you have to group wherever there is 1. So 1 is here. So you have to write the logical expression for this. So you have A0, so sorry, you have A as 1 here and you have B as 0 here. So what will be the expression? A and B naught. So A and B naught. Okay, this is the one part. Then you have 1 here. So what is the expression? A we have 0 and B we have 1. So A we have 0. 0 means A naught. B we have 1. So B. A naught B. A naught B. So the combination of these two, A B naught, which is this one, and A naught B. A naught B. So the OR of these two. The OR of these two is the difference. Whereas for borrow, we have only 1 here. Okay. So how the borrow is done. So I will be explaining you that. So basically, the difference output results the result of subtracting B from A. The borrow output indicates whether a borrow is needed when A is smaller than B. Whenever A is smaller than B, then a borrow is needed. Okay. So see here, A and B were equal, so borrow was not required. So borrow was 0 here. In this, A was greater than B, so borrow was not required, so it was 0 again. Here A and B were equal, again the borrow was not required, so it was 0 here. Here A was small and B was large. That is the reason borrow was required here, because A was 0, B was 1. That's why borrow was required. So that's why borrow is 1 only in this case. Okay, now you got that. So for borrow, again you have to write the expression. For A you have two different values. Again you can write this interchangeably. Here they have taken A. So for A you have two different values, 0 and 1. For B you have two different values, 0 and 1. So for 0 0, 0 1, 1 0, 1 1 you have to write. So for borrow, where we got 1? We got 1 for A0 B1. So for A0 B1, here A0 B1, A is 0 here and B is 1 here. So only in this case we got 1. So we will encircle this and we will write the expression. So for 1, what will be the expression? A is 0, B is 1. So A naught B. A naught B. So this is the expression for borrow. Same thing is implemented in this form of circuit, whereas the difference was A XOR B, just the difference. So difference was directly written with this, whereas for borrow it was A not B. So A will take a not means inverter. So they have provided here inverter circuit. So A naught and the other input is B. So A naught and B. So AND of these two gives you the borrow. So this is the half subtractor circuit. Okay, I hope you understand this.